Hello, y'all. We're going to get ready and do our first day of lessons remotely. Hope y'all are having fun being home. At least you get to come to school in your pajamas, right? All right. Our first video is going to be over the beginning of business calculus. You can print the notes if you want them. They're online. If you need to do that, you can pause. Also, make sure you have your calculator. If you don't have your calculator handy, then go grab it and pause the video and then you can put it back on. This is already written on because I already taught this lesson and I forgot to hit the record button, so bear with me here. I'll write on paper over it. So what we're going to look at is, y'all know that our two major functions in calculus are taking the derivative and integrating. Day one, we're going to work on derivative functions. Day two, we'll work on integration. So have your calculator ready, and you know you can use a Math 8. Calculator's okay in this whole unit, so we'll look at this. A big vocab word you're going to learn today is, well, marginal. If you look at this, we often use rates of change in the field of economics. Economists refer to marginal profit, marginal revenue, and marginal cost as the rates of change. And right there, when you see rates of change, you know that marginal is really code for derivative. So anytime they're telling you to find marginal, you need to find the derivative. So let's write that down. Marginal, means, I'm trying to look at my screen so I know what you guys see, and then I'm going all off crazy. Okay, so your big vocabulary word today is to know that marginal means derivative. Marginal means selling one more unit. So think of that. If you see marginal, you're going to try to find the derivative. Okay, so if you printed your notes, you can see these. If not, you'll need to pull them up on your phone or something. So we've got this formula, P equals R minus C. That means profit equals revenue minus cost. That should make sense. Revenue is what you have. So if you sold a bunch of stuff, the money people paid you would be your revenue. We've got to take away the cost. So if I went and bought 20 phones at $10 each, I spent $200. That's my cost. And then if I sell them to you guys for $50 each, then the revenue, what you paid me, would be the revenue. And then of course, profit is going to be how much money you have minus the cost that it took for you to get those things. And something I want you to notice, right, is that these are all capital letters. R, C, and P are, R stands for revenue, C stands for cost, P stands for profit in capitals. If we use lowercase letters, those are going to stand for something else. So make sure that you notice these are capital letters, okay? If P equals R minus C, then if we take the derivative of each one of those, then we know that the derivative of profit equals the derivative of revenue minus the derivative of cost. They stay the same, except here we've taken the derivative. Derivative again means marginal. Notice that we are having a dx now instead of a dt like we did with some of our previous problems. The reason being, X refers to the number of units sold or produced. So our cost and our revenue and our profit are going to depend on how many that we sold. Okay, so all capital letters. All right, let's look at a problem over here. Again, I did this once and I didn't have it on record. I hope I'm recording now. The profit derived from selling X units of an alarm clock is given by the function P equals 0.0002x cubed plus 10x. Find the marginal profit for 50 units. So you have two choices here, y'all. You can find dp dx, okay, and that's just the derivative, so that's 3 times 2, right? 0.0006x squared plus 10, right? And now we can plug in. It said it wants us to do it for 50, so we can plug in a 50 here. right? And you can do that with your calculator. So this is what you're doing. So take a second and put that in with your calculator. Okay, and you should get 1150. Now, if you don't feel like taking the derivative, you can go to Math 8, right? So I'm going to put my calculator screen there. Hopefully you can see that. It's kind of dark. There we go. So, why is my light so dark? Hold on. Let me clear it. Okay, so make sure that your calculator's cleared. Okay, so I took the derivative by hand here, but we could go Math 8, right? And we could just type this in. Our letter's going to be x. Now, when you type it in, you don't want to type in dp dx because this is the derivative that you did. If you want your calculator to take the derivative, then you've got to go up here and type in. So 0.0002 x cubed, right? Plus 10x. So again, you're typing in the original, then over here you tell it you want 50 and you hit enter and you're going to get the same answer. So I want to show you both methods. I'm perfectly happy right now if you want to type into your calculator and you don't want to do this derivative. This is good practice for you. You can do it both ways to make sure you have it. The key thing that you need to remember, if you want to use the calculator, you've got to use the original. If you were to type this into the calculator, then you'd be dealing with the second derivative because you'd be taking the derivative of what you already took the derivative of. Okay? So now let's look at question B. It says to compare the actual gain. If you see the word actual, that means to plug it into the original. So this means that we want to find P of 50. So you would just plug 50 into this, and if you look that up, use your calculator. It's going to come out to 525. And then if you plug P of 51 in, that's going to come out to 536.53. And if you subtract those, right, P of 51 minus P of 50, we get 1153. So this is actual, and this is a prediction with math. Hopefully you're getting the big idea, okay? And look at the difference between these two, okay? Let's wrap up what we just talked about. If I take the derivative and plug a number in, I am figuring out what I predict it's going to cost to make one more, or to move over one and to make that. If I plug, it could be any number, 60, 61, we just plugged them in here. If I plug in a number and one more into the actual equation to start with, it should match up with what my derivative told me. This is a little bit easier. If I take the derivative, I just have to plug the 50 in and it tells me 1150, right? That's the marginal profit for 50 units. And then if I go up one, it tells me how much I'm going to make. So this, you can see those are the same things. So the derivative is up one, okay? So look at those directions and make sure that that makes sense to you. Again, do you actually have to take the derivative here? You do not. You can go to your calculator and you can use Math 8, but then you're going to plug in P, not dP. Keep that in mind. You do not plug dP into a derivative or you're taking the derivative twice, okay? All right, not too much more. I promise I'll hurry. Something I want you to notice in the previous example, It's unusual in that profit continues to increase as the number of units sold increases. In practice, we encounter situations in which sales can be increased only by lowering the price of the item. Y'all are familiar with that. If the store puts something on sale, you buy more. The number of units that consumers are willing to purchase at a given price is given by the demand function P equals f of x. Now this is a lowercase p. Please don't get it mixed up with a capital P. The capital P is profit. This is really standing for price. So I like to put a little tail on mine. Somehow make sure that you can tell that's a lowercase p. So the little p stands for price. How much are you going to pay? $1.50, $2.70. What are you willing to pay? Now, if we know the price, we can multiply that by X, the number of units sold, and that'll give us revenue. And that makes sense, right? Because if I sold 20 at $1 each, I would bring in $20. So now you have a new way to find revenue. You just have to take your price and multiply it by X. That means everybody goes up one power, right? Okay, so let's look at this problem. This problem is really, I have a way to make it really, really easy for you. If you look in some textbooks, sometimes they make it a little bit more confusing. So I'm going to show you the easy way. Remember, revenue equals X times P, and make sure you know that's a lowercase p. So what we can do here is use a linear equation that y'all are very familiar with. Y minus Y1 equals M times X minus X1. Yes, point slope. Woohoo! The thing I want to put in your head right now is instead of using Y, we're going to use P. Y is going to be the price. Okay, keep that in mind. So now if we read this, a business sells 2,000 items at a price of $10 each. I'm telling you that price is the P. That's easy to remember. Y. So that's going to give us the point 2,000 items at a price of $10. It is estimated that the monthly sales will increase 250 units for each 25-cent reduction. So sales will increase by 250, so that brings this up to 22.50. If I bring the price down by a quarter, so that brings this to 9.75. So now if you have 2 points, you really can find the slope pretty easily, right? So let's find the slope. That would be 9.75 minus 10 over 2250 minus 2,000. And if you need to pause the video to use your calculator, go ahead. It is important that you key in things so you know how we got the answer. So there's my slope. So now what I'm going to do is I'm going to say P minus, right? And I'm going to use this one, so I'm circling it. P minus 10 equals negative 0.001 times X minus 2,000. See, it's simply a line that we used to do a long time ago. And now you'll just simplify this. You know, distribute your slope, and that's going to make that nice and small. Right? And now we'll add 10 to both sides. So this is our function for price. Now, how do we find revenue? So this is our demand function. Let's write that in another color. So this is demand, right? You can think of demand as the price. And now it wants us to find revenue. Well, remember, oh, I want a different color. Okay. Revenue equals X times P. So all we have to do is say R equals X times, right? And if you distribute that through, we have R equals negative 0.001 X squared plus 12X. Okay, so anytime that you are given a problem where they're giving you items and price, you're going to use point slope form to get that done. Okay. All right, I'm going to close this video, and we've got 2 more problems to do, but I'm going to put those on a second video because this is a lot of material and I think you need a break. I will see you when you join me for the next video. Oh my gosh.